Welcome to the IM2 video lecture. This is covering solving an equation by completing the square part 1. The learning target is for you to understand how to complete the square to solve an equation. The success criteria: 1. You should be able to find 1/2 of the b term. 2. You can square a number. 3. You can add a number to both sides of an equation. And 4. You can factor a perfect number out. We'll take a look at the expiration. Number 1. On the left hand side, it's x squared plus 6x plus 9. On the right hand side, it's just x squared plus 6x. So, what do you notice? What do you wonder? The left hand side, we would call this a complete of the standard form. The reason why it's complete is because it has all three things. It has an ax squared term plus bx term and a c term. This is beautiful because a is equal to 1, b equals to 6, and c equals to 9. You could factor in using out the diamond method. You should get x plus 3 times x plus 3. This is considered to be something called a perfect trinomial. Okay? The reason why it's perfect trinomial is because their factors are the same thing. X plus 3 times x plus 3. So your solutions are x minus 3 and x minus 3. On the right hand side, you should notice something is actually missing. The c term is missing. This is called an incomplete. This is an incomplete standard form. You can't do anything here. So what we are going to do is we're actually going to complete the square now. This is the process of turning this incomplete standard form into the complete standard form. Okay, this is the process of completing the square. In your courses, your teacher might also show you visually how this looks like, but I'm not going to be showing that. All right, so let's see how we got x squared plus 6x into x squared plus 6x plus 9. Let's see where that 9 comes from. All right, so this is the core concept of completing the square. First thing, you want to find the b term. The b term is the coefficient that is in front of the x. So remember, this is ax squared plus bx. So here your c was your 6. Your b is equal to your 6. Step 1 is to halve the b term, so 6 divided by 2 is equal to 3. Now, step 2, you're going to square that new number, so 3 squared becomes 9. This is your magic number. This is your magic number. You might see that, or you might hear this as the new constant. That is what it's called. This new number is called the new constant, and it's the number that you need to add here to the end, right, to complete the square. So in that case, we have originally x squared plus 6x. Now we're going to add that 9. Remember, in that process of adding 9 to the left-hand side, you also have to add it to the right-hand side of the equation. This is the new complete standard form. If we factor, remember, this was a perfect trinomial. So this can just factor out to be x plus 3 times x plus 3. That's going to equal to 9. If you want to know where this 3 comes from, it's in the b term here. The b term from step 1, this is going to show you here. This is going to give you the factors for the perfect trinomial. All right. So after that, x plus 3 times x plus 3 can be written in condensed form to just be x plus 3 squared is equal to 9. But there you go. This is the process of completing the square. let's complete the square for another problem. X squared plus 10x is, that's what we have. So step 0 is to find the b term. B here is equal to 10. Then next, we're going to have that b term. 10 divided by 2 is 5. Square both that number, so it becomes 5 squared. That new number is 25. 5 squared is equal to 25. That new number is called the constant that you add to complete the square. So originally, you have x squared plus 10x. Now we add 25 to both sides. It becomes x squared plus 10x plus 25 equals to 25. This is the complete standard form. If you factor it out, it just becomes x plus 5 times x plus 5 equals to 25. In a condensed form, you get x plus 5 squared is equal to 25. So there you go. Now, you might wonder, what happens, like in example 4, when that b term is an odd number? Nothing changed, really. So here, b is still equal to 3. Then 3 divided by 2 is equal to 1.5. That's half of 3. Now you're going to square it. So 1.5 squared is going to be equal to 2.25. So you have x squared plus 3x. We add 2.25 to the left and add 2.25 to the right. In factor form, it's very straightforward. This is going to be my factor for the trinomial. So it's x plus 1.5, x plus 1.5. That's going to be equal to 2.25. In condensed form, it just becomes x plus 1.5 squared is equal to 2.25. But there you go. So the process is the same when the b term is an odd number. All right, next. Here, it's asked us to complete the square and factor, okay? All right, and solve, right? So we want to make sure that we solve this as well, right? So complete the square and factor, right? So notice that here, x squared plus 10x minus 4 equals to 0. You cannot diamond method this. You can, but it's impossible. You can't find two numbers that multiply to negative 4 that adds to 10, right? So let's complete the square. So step -1 is to move that constant to the other side. So we add 4 to both sides, right? In that process, you get x squared plus 10x is equal to 4. Now, the x squared plus 10x looks like what we did before. So we just find the b term. The b term is equal to 10. Step 1 is to half the b term. So 10 divided by 2 just becomes 5. Now we square. 5 squared is equal to 25. That new number is called the constant that we add to both sides to complete the square. Step 3, we add the new constant to both sides. X squared plus 10x plus 25 is equal to that number 4, which was already there, plus 25. This is the complete new standard form. Now you can factor it. X squared plus 10x plus 25 is equal to just x plus 5 times x plus 5. On the right hand side, there's a 4. So 4 plus 25 just becomes 29. In condensed form, it looks like x plus 5 squared is equal to 29. So notice now we basically have it in factored form. And now you could essentially solve it if you would like. Okay, but there you go. This is how you complete the square when you have a situation like this. Completing the square allows you to basically factor it, because right here, this was unfactorable. Unfactorable. Okay, factorable. Okay, you couldn't unfactorable. You couldn't do that. But this whole process, right, made it now factorable. Okay, and it became that. All right, that is the usefulness of the completing the square.